Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd take a look at another little radio set. What we've got here, this is a VEGA 404. This is a Soviet radio made in the former USSR. I think I might have shown this on a video before when I was going through some little pocket transistor radios. It's not working, so I thought what we'd do in this video is have a quick look, see if we can actually get this thing playing again. Now, I don't think I've ever had this radio working. I'm not 100% sure where it came from. Probably, like I said, in a job lot of radios that I bought for another radio, and this just happened to be one. But I have kept hold of it. I managed to print the circuit diagram out for it, thanks to radiomuseum.org again. They are very, very handy for the more obscure stuff. I mean, generally speaking, if it's a UK set, I've got it in my radio and TV servicing books, but like I said, this is a foreign set, little bit unusual. It's interesting design, really, more than anything. I mean, it's a shoulder strap radio. It really was designed to be worn a bit like a handbag type pair with a strap that goes around here. Dates from 1978, so it's probably one of the later Soviet sets. I mean, most Soviet radios and TVs were 60s and 70s, and especially the TVs. I think they were quite popular in 70s. Some of the little VEGA sets. VEGA was a brand that you saw on a lot of Russian-made stuff, well, Soviet-made stuff, because it weren't just made in Russia; it was made all over the Soviet Union. So what I thought we'd do, we'll pop a battery in it and see what it's actually doing. Oh, yeah, that's what getting off my tail anyway. I printed the circuit out for it, and what I've discovered is that this thing uses a radio IC. So it's one of these sets that if it's the radio IC that's faulty, I'm not 100% sure what we can do with it. I might, with the ones of the internet, be able to get a replacement for it now. But certainly back, a few years ago, if the radio IC had been dead in this, it would have been absolute scrap. We could get lucky and not be the radio IC. There are a few transistors in there as well. There will be some electrolytic capacitors, and from past experience of this Soviet-made stuff, some of the electrolytics aren't brilliant in them, and I've had to replace a few. My little signal there, I had to change a few electrolytics in that to get it to play, and various other Russian sets and Soviet sets I've played with. Similar things with the capacitors in them. So I'll pop a battery in it anyway. We can use a little PP3. Battery arrangement on this thing's quite unusual as well. We open the battery compartment in the back there. In fact, let's see what it says on the back for battery, if it says anything. Oh no, it just gives you long wave and medium wave coverage. Power output, it's giving you as 0.4 watts, so just under half a watt. And made in USSR, so nothing about the batteries actually on the battery compartment. We've actually got that's the shoulder strap for it. We do actually have the shoulder strap, and it's actually still in reasonable condition as well, so that's quite nice. Most of these I've seen, the strap's gone or has been broken. But then we've got this this strange thing here. Now it's got a PP3 battery snap on it there, but it also has other spring contacts on it, and I believe you could get there should be a piece of plastic in here that has other contacts in it and allows you to use 6 AA batteries to power this. But it looks like they also give provision for a PP3, so that's what we're going to use anyway, because I don't have the plastic carrier for the batteries. So we'll plug that on there. We'll switch on. We heard. We get a pop out of it, but that's it. There's nothing else. You just get that one pop when you switch on, as you can hear. I don't even think the dial illumination works. No, so the bulb's probably gone for that. It is just a momentary push switch, obviously, to conserve battery, but that doesn't appear to do anything. So we seem to have some life in the amplifier, but apart from that, absolutely nothing. We can see if the local oscillator's doing anything. We'll switch it on. And I've got that little Phillips that we repaired in a previous video, the one that led me up the garden path, and we'll just see if we can get the pick up the local oscillator. Let's have a well, that seems to be tuning across this radio, just there. Can you hear it there? We'll turn over. There we go. So I think the local oscillator is running in it. So it sounds like we've got something happening in the audio section. It sounds like the local oscillator is running. So I wonder what could be wrong. We could actually get lucky and it just be a bad electrolytic or something like that. We'll crack into it and see what we find anyway. Get the back off. No, I'm not sure whether the IC runs the IF. I'm not really looked at the circuit yet. I think usually on sets I've seen that do use an IC, it does most of the work really, and then you just usually have an output stage. I'm presuming this is going to be done something similar. Right, what else do I have to take out? Just that. I don't really want to, force on anything, especially being that this is 1970s Russian plastic, and Russian plastic's not known for its quality. Ah, there we go. Russian plastic isn't known for its quality. I know I've got quite a few Russian Spectrum clones in my collection, and the plastic they're made out of isn't good. Not compared with like UK and even Chinese plastic's better than 60s, 70s, 80s, and even 90s Russian plastic. It's a bit cheap, shall we say? And we'll put the back to one side. Although this seems better than most, I must admit. Especially this yellow plastic looks quite good. Right. Now what have we got? Let's see what we can spot in here. Build quality actually looks pretty good. Now these are them electrolytic capacitors that can give issues. So we've got 1, 2, 3, 4, 5, 6 of them. I think that's the other thing with Soviet stuff. It could take a little bit of looking at, because the components don't look quite like what you usually find in like UK built stuff or European built stuff or even like American built stuff. This did seem to do things a little bit different at the other side of the Iron Curtain. We've got like the standard little round disc capacitors you find. Generally speaking, the Russian ones tend to be square. So we've got some little very, very thin disc capacitors. I've seen very similar to these again in like the Russian Spectrum clones, the Soviet Spectrum clones. I'm trying to see where the transistors are. Is that a transistor? Ah, right. We've got V2. What's that there? Ah, that's V1. So we've got V1, V2, V4. So where's... I presume there should be another transistor, a transistor 3 somewhere. I can't spot it though. There's our volume control there. Got some trimmers. It doesn't seem to be an awful lot in here really. There's our IC, so that's basically most of the radio is that one IC under that heatsink there. Is that the output stage as well? You know what, that could actually be the output stage on this thing as well. That's going to be fun. Well, I wonder if that isn't dead then, because we definitely get a pop out of it. I wonder if we can get a buzz out of it if we try touching the volume with something. Let's give that a go, see if we've got any life actually in the output stage. So we'll connect the battery up, we'll switch on. Didn't hear a pop that time. Oh, there we go. And let's have a go. I'm just trying to introduce like a bit of buzz by touching the volume, but I'm not getting anything. I think we've got a contact there. Let's make sure we've got our volumes. No, it's all the way on. I don't seem to be getting any buzz. No, I'm not getting any buzz at all when I touch the like the wiper or any sides of the volume control. That's not a good sign. We could have it could be the IC, which is bad, unfortunately. Or we could have I think we've got a bit of a bad contact on the battery as well. We'll address that. I want to know where that other transistor is though, because we've got 1, 2 and 4, so where's 3? I can't see the other transistor, so where on earth is it? Am I just being thick and not seeing it? Or is it on the other side of the board? It could be on the other side of the board, you know. Because like I said, if it isn't one of these capacitors, which I'm hoping is the fault, the next thing is it's going to be either possibly one of the transistors, or it's possibly going to be the IC there. I suppose we better get the board out of the case and have a look on the other side. What I don't want to do is mess up the dial pointer, although, that being said, the tuning dial on this is very stiff, so it would be nice to see if we can get in there and perhaps add a little bit of grease to the pivot points, see if we can free it up a little bit. See if we can get these standoffs out. I presume this is how you get the chassis out, the PCB. That's one out. You get a bigger flat blade for doing this really, but I think I can get it with this one. Let's see if that'll go. Yeah. Might stand a little bit more chance if we can see the other side of the board as well. Right, let's see if that'll get us the PCB free. Right, I think it's just the volume control holding it in place. We might need 2 screwdrivers to get that out. Let's see if we've got another flatty. There we go. Right, let's have a go at this. One on that side, one on that side, and let's hopefully not fire the volume control across the room. There we go, we should be able to get our fingers under that now. And off it comes. Right, hopefully that should have got us the, let's disconnect the battery. That should have got us the PCB free, and let's hope we can get it out without messing the tuning up. Yes we can, excellent. We haven't got another transistor on that side though. Right, I wonder if we should get the... How does that look? How does that look come free? Oh no, that's going to be for the dial bulb. So what's the other? What on earth's that for then? We can disconnect that from there. That I presume is the... Oh, I don't know what they're doing here. I was going to say this looks quite nice to service, but I'm just about to take that back, because you can't... How do I get that from out of there? Does it just pull out or what? Does it all pull out as one piece? I'm limited basically by you've got a DC in jack and a headphone socket here, and I'm not sure how they come free. And they're the wires are very close for getting the board out. This is a bit of a pain. I haven't made this easy. No, you've got virtually no room at all to get that out. So how are you meant to get that out? Is that pushed down and out or what? I've made that really difficult when it could have been really easy. I don't want to risk breaking anything. Try to manipulate it out. Well, hang on. Ah, right. So the whole. Right. Okay, that's possibly made it a little bit easier. So we'll take that off, and then does this come out as a unit? It looks like it might do. Or do these just slide out? Right. So that's the headphone socket there. That's free. And the DC in jack seems to be... Does that whole thing... No, that's fixed as part of that. So you've got a... That's a miter. You know, just screw these two little screws to free off the DC in jack. I don't think I'd ever use this thing plugged into a mains outlet or anything. Well, a wall wart or anything. It probably is just going to get used on batteries, but I'm not just going to cut the wires to it. Someone in the future may want to use it like that. Right, okay, so that's that disconnected. Now, shall we possibly take the speaker out? Then we should at least have it completely out of the case. It might make life a little bit easier to work on it. Right, and we can have a look at this speaker. This speaker looks quite nice. They just did things a little bit differently in the Soviet Union than anyone else. Come on, out you come. I was expecting... Ah, there we go. Yeah, you can just pull it out. Right, now let's get the battery. We can get... Should be able to get... There we are. We're not out of the way completely, but at least we can... So where's that one going to? And I can understand why there's the button to there, because it'd be for the light. So is that... What's that thing there? X3. That's most odd. Now those two wires are going towards the switch. Now, so those must go towards the dial light, but what's that thing? I don't know if you can see what. I'll just zoom you in so you can see what I'm rambling on about. It looks scarily high voltage actually. Basically what we've got these two white wires here, which I'm pretty certain go to that momentary switch. But we have the other two wires, which I presume go to the dial light, come through this unit here with the wires there, and it's just marked as X3. So what is that? I don't think it's anything to do with the fact the radio isn't working. I think it's something to do with like the dial light or something. In fact, I might just oh, I've not even switched my soldering iron on. But switch the soldering iron on, we can get that warming up. But what is that? That's most odd. Because what I'd like to do is just disconnect them for the moment. Oops, let's get you zoom back out a little bit, and then we can actually play more with the radio and get that out of the way. I think my soldering is just warmed up. Let's have a go. See if we can desolder that, and then like I said, we've just got the board to play with for the moment. I don't think having them connect is going to be critical. That's that disconnected. That's that one disconnected. And then we can perhaps have a look at the front and try and find out what on earth they do. Turn that round. Right. Let's see if we can get these wires out. That one goes there. There we go. That's disconnected. And that one goes there. They're both the same, you know, you've got two whites and two reds, so I don't think there's any polarity on them connections. It doesn't look like there will be anyway. Right, so we can get that out of the way and we'll have a look at that. Yeah, because it looks like we can get that mechanism out as one. It's got just a light bulb in there, I can see it now. We can spot it, but it's just in there. It's just like a standard torch bulb. So it does indeed look like that's what they go to. So what is that strange thing? Most odd. Right. Now let's see if we can find any signs of life out of this thing. Let's plug the battery back in. That's really bad contact, that. I might have to do something about that straight away, actually. I wonder if I get rid of that and just fit a normal PP3 battery snap, because I've said that I'm only going to really use this for the PP3, but see if we get any. I can. As I play with the battery, I can hear a little bit of rustling in the speaker, but that's about it. So we're just getting that pop as you power up. You're getting absolutely nothing else. So, yeah, we're just getting that one pop as you switch on. very nicely made speaker. Alright, let's disconnect that for now. Let's take a look at the old schematic. Right, let's get them screws somewhere safe. Where can I put them where they're going to be safe? I'll stick them on that speaker there, because they'll stick to that. Right, I'll get you zoomed in a little bit. Oops, wrong way. Down a little bit, I think. Right. Can we get the camera? Let's try and bring you that way a bit. Can we get you down on the circuit diagram so we can both see it? Let's have a look. Oops, wrong way again. Right. Down a bit. Alright, now where am I looking at on the board on here? Right. Okay, let's have a look at capacitors. Let's see if there's any of them electrolytics that we could find that will absolutely kill the radio like that. Now, where have we got one? That's the only other problem. This is a Russian schematic diagram. Some things are dead simple, like transistors. I mean, the symbol for a transistor is pretty easy to identify, but certain things can be a little bit more tricky. Although, actually, no, we've got capacitor there, and the symbol for the capacitor is like the normal symbol, 2 lines separating, and it even has a plus on it, so we can see that that's an electrolytic capacitor. That seems to be the only way you can differentiate an electrolytic between a standard, though, is the electrolytics have a plus on one side. This is where ours, you usually have one side's thicker than the other, or one side's like a box and the other side's a line. But it's, you know, after a while you can start figuring these things out. It's not a major issue. Right, so yeah, we've got a capacitor there that if that was shorted out, I think that would cause issues. Then again, I think if that shorted out, then it'd be shorting the battery out pretty, pull your battery voltage down pretty damn quick. So look at the audio output stage. Where's the audio output stage? Here we are. And yes, indeed. Sorry, I don't know if you can see what I'm pointing at here. I don't actually know if you can see this on the camera. I need to sort something out so you can actually see the circuit diagram a little bit better. But if we have a look round here, it does indeed look like the audio output actually comes from that IC. That's the IC there, basically. It shows you basically made up out of various transistors, and I'm sure there's lots of other bits in there. But it looks like your audio output stages in that as well. We do interestingly have a capacitor on that IC off pin 5 going to ground. Now if that one had gone, that's going to stop the IC really working. That could be one we need to check out. That's C22. So as a stab in the dark, let's have a look at C22 and see if that's where our issue is. And one great thing that I do like, oops, let's get you up a little bit. There we go, that's better. One thing that I do like is the board is actually marked up. It's screen printed, telling you where everything is. So we've got R24, X3, which is that strange thing, C6, C5, C4. So all we want to do is find, what did we say, C22, and we'll start our search at C22. C21, C20, C24, C27. Come on, where are you? C23. It's going to be elusive, isn't it? Where are you, you little bugger? C28, C29. Come on, where's C22? C31, C37, C4, oh, we've already been there. C14, where is C22? We'll find it in a minute. That's C28, 29, C34, C22, it's down there. So it's that, oh, it's that capacitor there. So let's take that off the board, we'll test it. What are you? What is C22? It's 50 UF, so we should easily be able to find a replacement for that. Let's whip that off the board and we can do a quick test on it anyway. It's probably the first thing to do. I suppose this would be a good good set to use that old Shango 066 trick and play some audio through the capacitors and hear what they sound like. Because you're not going to do any real damage to the set, I don't think, doing that. Although you have got an IC in there, I don't think you'd do any damage. It'd be interesting way of identifying any bad caps in it. But I think we'll whip them out. Right, there we go, that's that one out. Doesn't look particularly swelled or anything, no nasty smells have come out of it, but we can still we'll test that. We'll get the old analyzer out, get some leads out for it. Right, we're going to need 2 wires for this. Right, 1 and 2. Put that in there. Put that in there. Hopefully you can see that on shot. I don't know, can you? Possibly. We'll connect the capacitor up to it. Now this should be a 50 UF capacitor. No, yes, there's K50 on the actual can. Let's see what this tester makes of it. Oh, actually it's fine, 50.1 UF. So that's absolutely fine. I think we can put that one back in actually. I'd rather leave the radio. Let's figure out which way around it is though. In fact, which way round? I should have a plus marked on it somewhere. But it doesn't. Oh. Is that a minus on that side? I don't know. There's that bit of paint there to designate plus. Have a look at some of the other ones. That's a 50 there. And that one's marked with a plus. It doesn't say it's a non-polarised because it gives a plus mark on the actual circuit diagram and it gives a plus mark on the PCB. Oh. Well, that's fun, isn't it? So we're going to have to replace that just for the sheer fact that I'm not 100% sure which way round it should go. Oh well, what a bugger. Oh, hang on, let's have a look at that one. Is that one the same? Yeah, that one's the same. That one hasn't marked. But can we figure out, looking at that one, which orientation that's in? The plus is on that side. So we bring that one round to... Oh no, so even the printing's not in the same place. Oh. Well, that's a bugger. We've got a 50 UF capacitor kicking about. I can replace that one with that. I know what the actual what's the actual polarity is. I should have really marked it. I didn't actually realise that it's not marked on the can. The other ones are, but this one and that one there aren't. So the polarity is marked on the board, so I can I can mark up and put a little paint spot on it. But this one, no, and those ones, that one and that one, have a plus marked on them. They're a different type anyway. They seem to be sealed in the middle rather than with a plastic bit at the end, as that one is. Just bear with me a minute, folks. I'll just have to go and see if I can find a standard 50 UF capacitor to put in there. That's annoying, that. Back in a sec. Okay, excuse me. Okay, well I found one. That's really annoying, that. I won't throw that capacitor away because I will try and figure out which way around it should go. But at least we can stick this in here, and it is a brand new 47 UF, so it's close enough. Oh, and them holes haven't cleared either. Damn it! They look clear from that side because I can see the. I don't think that's going to be a problem. Why you no go through the hole? Oh, there we go. That's gone. That one's being awkward. I'll have to give that one another little suck, I think. Hopefully that should do it this time. That's rather annoying, that. But let me just give these legs on this, it's a brand new component, but it has been in storage for a while, so I'm just going to give the legs a little scrape clean, because they do look a little on the tarnished side. Just aids with soldering, if you make sure your legs are nice and clean. You can do what I'm doing, which is just giving them a quick scrape with a Stanley blade, or you can rub them with a little bit of emery paper or something. You just want to make sure there's no tarnish or corrosion on them before you attempt to solder them in place. Right, let's give that another go. You've gone through there. Go on, in you go. There we go. Get that slightly unnecessary new capacitor in there. Little bit annoyed about that, but it's not the end of the world. And it does mean that there is a nice new component in that place in the board. So it won't not benefit from having a new component in there. I've just got to remember when I have a look at the other ones. Well, the other one that's the same type as that one. That there's no polarity markings on them. I don't think it's a non-polarised capacitor, otherwise it wouldn't have been marked as a polarised one both on the schematic and on the PCB. In fact, well, I think what I'm just going to do is I'm just going to go through them all and test them. So I've got a feeling that it's either going to be, although that was the one I was kind of thinking if that had shorted, that would take out the IC. I don't think there's anything wrong. I doubt it's going to fire up just by changing that, but we'll see if there's any change at all. No. Nope, nothing there. Well, that's the other thing. Could we have a dodgy wave change switch? Although, if you had a dodgy wave change switch, I'd still expect to hear more from the audio than we're hearing. We're just getting that little bit of a pop and that's it. So I suppose C36, let's have a look where C36 is in the circuit. And now C37 could be a possibility. That again is coming off the IC. So I'm feeling something is killing the audio because we're not getting, we're touching the volume control there should get us at least a little buzz or something, and we're not. So something seems to be stopping the audio actually working. And if it was just one of the transistors in the other part of the circuit, being the fact that the main IC actually is the audio amplifier, I'd still expect touching that to give us a buzz. So where is C36 we said, didn't we? Yeah, we said, well, we've got, we want the electrolytic, which is that one, which is, yeah, C36. So it would be nice to see where that is, if it's anywhere, anything to do with the IC. We know C37 is, so when we find C37 we can definitely check that out. Let's try and see where C36 is. Ah, there. Right, again, yeah, it does go into the audio IC. Audio IC. It's more than just an audio IC. It's most of the radio, to be honest. So let's try pulling, and that one at least is marked a little plus, yeah, plus in the right place. So let's whip that one out. So I have a feeling it may well be one of these. If it's not one of these, then I've got the horrible feeling it could be the IC itself. Let's take the battery out while we play. One thing I'll say is that the actual PCB in this is far, far better than you find in the Soviet Spectrum clones. These PCBs in them that I've worked on tend to be really, really flaky. You just show them the soldering iron and they lift traces. As where this does seem to be somewhat better. Let's see if we can rock that out now. Come out that way. Oops. Come on, out you come. my over workbench lighting seems to be doing some daft things, so if it starts flickering a bit, I do apologise. I think I might have a LED on its way out. It wouldn't surprise me, it is made out of an old scrap LED TV. Right, so that's come out. Again, what size is that one? I think that might be another 50. I think this radio might be actually slightly later. They said 78 for these, but this seems to have a date code of 0582, and I think the speaker had a date code of 82 on it. I'm sure it did. Yes, it did. Something 4782. So this looks like it was made in 1982. So they must have still been manufacturing this stuff up into the 80s. But I do know from the circuit and everything, it's a 78. 78 was when these came out. Right, let's give that one a quick test and see if that's any good. Now, what did we say it was? It's that one there, 36. It's another 50. Yeah, it does say 50 on it. If this one's all right, it's going straight back in the radio. So we'll see what the magic meter makes of it. Ah, 2 diodes anti-parallel. That's not 2 diodes anti-parallel. That's definitely a capacitor. Let's give it one more. You can't see that, can you? Let's give it one more try. Oh no! Now it comes up as a capacitor. Not quite a high capacitance for the capacitor it is. We'll try connecting it the other way around, and we'll give it another try and see what it comes up with this time. Well, it's coming up as a cap, but it's coming up quite a lot higher capacitance than it should be. It could have gone quite high ESI, that. I suppose, being that it's not healthy, I better go and find another 47 UF capacitor to replace that with. I better go and see if I can find a few. I have a feeling I might end up putting a few new capacitors in this anyway. Right, back very shortly as soon as I've found some spare capacitors. Don't know if we're going to bother wasting new ones on this, being that we don't know whether we're going to be able to get it working, but I'll see what I can find. So back shortly. Okay, well, I've gone ahead and I've changed. If you look, oops, you can't see that. Let me just get you up a little bit. As you can see, I've changed all the electrolytic capacitors, which basically are associated with the IC. Now, I've made a mistake. I thought that IC was more than it is. It's not. All the IC basically is the audio output IC. The rest of the radio really is all the rest of the circuit. That is just audio output. And we've changed all the electrolytics that are associated with it, and to be honest, none of these electrolytics are bad. I mean, that first one, obviously, you know, it was absolutely fine. All the others, they have drifted in value. They're all probably about 30–40% higher in value than where they should actually be, and that's a good indication that they've started to at least get to the end of their life. So I have gone ahead. There's only 2 left in there, that one there and one there. Now that one is technically, you know, in that part of the circuit. That's nothing to do with it at all. That's to do with the mixer oscillator. I might change them too, depending on what we find next. Because what I thought is, I'm going about this the wrong way. I thought it's probably a good idea to change them capacitors, because like I said, they were starting to drift in value, but none of them were the actual problem. And to be fair, if I'd have left them capacitors in there, the radio probably would still work absolutely fine, you know, once we've cleared the actual fault on it. So what I thought I'd do is, we'll see if we're actually getting anything out of this thing. We're going to try and bypass the output IC and see if the rest of the radio is actually working. So with that in mind, I've dug out a really crappy pair of old PC speakers, because I can't get access to my signal tracer at the moment, so we'll just improvise something. So I've got those crappy old PC speakers, and I had a rummage in my junk box and found that, which is the board off, so I think it's off an old, what do they call them, speakers that go under your sound bars, that's it. I think it's off an old sound bar, but what that allows me to do, I'll just switch the PC speakers on. Basically, that's the input off the back. So if I plug my speakers in there with the 3.5mm jack, on the other side, I've got some wires that are basically my output. So I've got a ground, and all I've done is connected the left and right together, and just put 100 UF cap on the end. That's purely to block any DC, because obviously we're going to be probing around on the radio. We don't really want to hit like 9 volts DC and send 9 volts DC up into the speakers, because the amplifiers don't like it. So that's purely what that cap's there to do. It's just to block any DC that we're going to encounter from getting actually into the speakers. So it's basically just a really crude DIY signal tracer. I've took the leads off my capacitor, my component analyzer, and I'm just going to literally crop clip these onto the wires that come off that board. So I'm going to go onto the positive of that little electrolytic cap that we connected, and I've just gone to ground. So if you look, just like that, which just gives us 2 test leads now. I mean, they're not brilliant test leads or anything, but it gives us something that we can probe onto the board with. Right, let's have a squiz. And I think, looking at the circuit diagram, I'm probably best just going straight off the volume control. If I've got this right, and that is just an audio IC, which I think it is, I had a feeling, you know, first I was thinking, no, it's got to be more of the radio, because there's only like 4 transistors. But it does look like that is literally, basically, just the audio output stage. So, I've also, I was getting fed up of the bad contact on that battery snap there, so I've literally just bodged in a 9-volt battery in a little case there, just to make testing a little bit easier. And it's got a little switch on it so I can isolate the battery while I'm working. I'll probably actually do away with that thing, because the contact on it's awful, and just put a normal PP3 battery snap when we're done. Right, let's have a play anyway. We'll switch the radio on, and are we on there? Yeah, we're actually on the radio at the moment. So what I thought we'd try, we need a good ground connection. So I suppose we could go straight off the battery for the ground, couldn't we? Because that's probably your best ground connection you'll get. Because it is, there are NPN transistors in this, so it is a negative earth system. If you ever worked on these old radios, a lot of the earlier stuff uses PNP transistors, and you've got a positive earth on the PNP radios. This uses NPN transistors, so it's got a negative earth, so negative on the negative of the battery. And we've got an audio, we've got a buzz there, so we can have a probe. What I'm going to just try first is straight on the centre of the volume controls, because that's where it should come out of the actual radio into the amplifier section. So we'll hold on there.
With any sort of light-heartedness this weekend, would they?
I think that pretty much concludes our problem.
Exactly, and I think it's...
See if we can tune the radio. This could be tricky. Can I hold that on there and try and tune the radio?
If you can't see them, and make sure you...
Yeah. Right. a bit tricky to tune just pulling the thing round, but
in the Lake District, but at the moment I'd rather have...
it does indeed look like the actual radio itself is working, and we just do have a an audio output stage problem. That in itself could be a problem, because I did have a look earlier on eBay to see if I could find that that IC. This is how I was I figured out it was actually just an audio output IC. I was searching for it and managed to find some data on it, and it just does say it's a like half-watt audio output IC. What is it? It's a K174YH46, I think. But there's loads, and if you actually look online, I haven't been able to find the exact data sheet for that part. But there's loads of Russian parts with a very similar number, and when you pull the data sheets up for them, they're all audio output. Various wattages, and some various slight variations, but they all seem to be a variation on a theme. There are British ICs, which actually Radio Museum do say that there's equivalents of, but when I look the data sheets up for them, they're like nearly 5-watt components. I'm sure in some situations you could probably bodge one in, but I don't think it actually work in this instance. So our option, I am wondering whether this is going to work or not, is we need to see what we can substitute that for. And I did have in my mind if that was going to be the issue, because after I changed them caps, I had absolutely no improvement when I tested the caps, and there was none bad. You know, they were failing rather than failed. So I am quite pleased I've put replacements in there, because it will prolong the the life of the radio. I probably will. Now I know definitely what the issue is. I'll probably go ahead and just change those last two as well, just so I know it's, everyone says, oh, you're just a blanket recapper, but they had started to drift, they'd started to fail. We might as well put a complete new set in here and have the radio reliable for a number more years. But anyway, let's get back. So what we need to do is figure out something to replace that with. And I've got an idea in my mind. I don't know if it's going to work or not. But what I was thinking was LM386. It's a very ambiguous little... anyone that's into electronics will know what an LM386 is. It's about, is it quarter or half watt? I think it's about half a watt. Little 8-pin audio output IC. The circuit to operate it is very, very, very simple. And I'm wondering if I could perhaps just make up a little board that will, because we've got a fair bit of space there. If you look at the heatsink on that, and the amount of space we've got on the board, I think we could perhaps get a little PCB that'll fit in that space there, that we can parasite off the board all the signals we need and the voltages that we need, and we'll just basically replace that with a little board that goes over it. I'll have to have a hunt round to see if I've actually got any LM386s. I have a feeling I've got some LM386s. They should work fine with a little 4-ohm speaker like that. And the radio it's rated at 0.4 watts, so I think I think it's between about quarter watt and half watt an LM386. So it should work alright. I'll give it a go anyway, because with nothing else to lose, I don't think I'm going to be able to get that with a direct replacement part. I mean, if I could, it'd be great. We'd whip that out, put the new one in, and everything would be hunky-dory. But even if I can get one of them, it'll probably be from, Poland, Russia, somewhere like that. The postage on the part's probably going to, and the cost of the part's probably going to outweigh the value of the radio. So if I can come up with a cheap, simple substitute we can just bang in there, it's more the best, especially if the radio plays right, because that's the aim of this, is just get the radio so it plays right. So I'm going to go and have a hunt round, see if I've got any LM386s, and see what I can come up with as a bit of a solution for this. So back in a sec. Okay, I've knocked this little board up here. Basically, what we've got, this is as simple as you can get for a little LM386 amplifier circuit. Oop, I've just stood. Oh, great! I've just stood on my glasses. Oh, bugger. Never mind. There are only some really cheap ready reader type ones, but damn, it's what I use while I'm soldering. Oh, bugger. Never mind. I'll put those to one side. I'll see if we can fix them later. Hopefully, I don't need them again. So anyway, basically, what we've got here. We've got the little. I've put it in a socket purely because I found a bit of board that had an 8-pin socket soldered to it. That was just a scrap bit of board from some other project. So that's why I used it. It's obviously it's also better to have your IC in the socket. I mean, you could just solder it straight on, I suppose. But what we've got 9 volts in on the red wire. We've got a ground connection there. We've got audio input on that grey wire there. That first capacitor there, that's not actually connected in circuit yet. That's a to set the gain. Basically, if you connect that in circuit, you get a higher gain on the amplifier. I don't know if we'll need that. I'm going to leave it out of circuit. I've just left a little place where I can just blob a bit of solder to bring that into circuit if I need it. Then we've got output capacitor. You've basically got one capacitor goes through a resistor to ground. The other side of that comes through. That's a 470 UF capacitor, and our audio output comes off there. I'm probably going to disconnect the speaker from the circuit and just connect, like I said, the plus there and the speaker ground to that connection there and drive it straight off this circuit and bypass basically whatever's on the original circuit that was to do with the audio. So really that's it. I mean, I've not tested this circuit yet, but I've used this configuration before. I'm fairly confident it's going to work. It's a little bit bigger than what was there, but it should fit. Let's have a quick squiz at the radio. I suppose what we better do is we might just lash this circuit in and actually see if the radio will play before we go to all the trouble of connecting this thing. I better get you zoomed out. Connecting this thing up proper. Just let me just get you down a bit so you can see what we're doing. I'll zoom you in a little bit. Right, there we go. That's going to have to do for now, I think. Right. So, I don't really want to mess about with the way that they've got the speaker connected up. It goes through. Let's have a look here. One. So obviously I don't want to muck up. We've got both power and speaker wires are both red, so that goes through the headphone port, doesn't it? Yeah, that goes through the headphone port. So, oh yeah, and I did try bypassing the headphone port just in case it was something simple like that, and no. Right. Let us have a think here now. That's speaker ground, I think, and the blue wire, because that goes to the that goes to the power input. Right, so we've got the white wire here's speaker ground, and the blue wires our actual speaker. So we can disconnect them from the main board, and we can connect them onto the. In fact, speaker ground goes to. Let's just try disconnecting. The speaker positive first. Yeah, let's try disconnecting the speaker positive first and just connecting that to the boards, because it should be able to still find the same path to ground. So we'll disconnect that wire there. that's going to go onto the new board. Now let's bring the board in. So we're just going to lash this up for now, just to see whether it's going to work. Now we're going to need 9 volts, aren't we? So where can we get our 9 volts from? We should be able to get it off the actual old chip, if I can figure out which wire goes straight to 9 volts. Let's turn that on. That's off there. Oops. Right, let's have a look. So we go straight off the battery, and what we're looking for is a dead short from the battery to the IC. Nope. There it is. So the M pin number, oh no, it's pin number 6 on the original audio output IC is our 9 volt feed. So let's, I'll have to just strip these wires. Right. I'll tin these wires up and we'll get this just loosely soldered into place. Just on the back of the radio. This is just a test, just to see whether the radio is going to play with this circuit, and if it does, then we can actually go ahead and fit it properly. I wish I hadn't broken my glasses now, because this is going to be tricky to solder up. Right, let's get in here. Tin that one up. Tin that up. Tin that one up. Right, okay, now let's connect power up first. So let's have a look. Where did we say? We said pin 6, didn't we? So pin 6, alright, it goes to that nice big solder pad there. We can, alright then, yeah, that's the right wire. That definitely goes to pin 6, so we'll solder that. It's only, we're only just tacking it on for now, because we'll probably, have we got that? No, it wasn't quite high enough. Let's add a little bit of solder to the board. Do you know if the conformal coated these boards or something? Because that's not sticking. Oh yeah, no, it's all right now. Right, so that's our power. That's our power connector to the our little bodge board. Now we want to connect ground up. Now which one's ground? That one's ground. We can pinch a ground straight from there, because that's the main ground for the radio. Because I can see that because there's an electrolytic capacitor right there, and that's going straight to it. And that trace runs all the way around the outside of the radio, so I'm pretty confident that's the main ground. Then we're going to connect this wire to the centre of the volume control. What we'll probably do is we'll find out where that is on the IC, but it's just for testing purposes. We can just connect it up like so. Then if we connect the original speaker to the new amplifier, so we may have to disconnect the ground there and connect the ground to the main amplifier, but I think actually that should be okay. I think it already goes to the ground. Let's just get a bit more solder on that connection there. Okay. Right. We'll solder speaker wire onto there. like that. Okay. Now, technically that should work. We're basically parasiting everything we need off the radio through our little amplifier IC there and to the original speaker, so that should work. Of course it should work if I actually put an IC in the board, which, yeah, otherwise it ain't going to work. I've got some brand new LM386s here, well, a few of them, so let's get one of these out. There we go. I've got 10 of them, I think. And put that in there. Keep that safe. Right, now this, hopefully, if you keep your fingers crossed, should work. Make sure we put this in the make sure we put this in here the right way around. So pin that way into, yeah, I've got that the right way around. That's pin 1 to the bottom corner. Right, so that's our, that's in. That's our little IC in there. So let's switch on and yeah, there's some volume there. I've turned the volume down a little bit just in case there's too much gain. Let's switch on. There we go. It's overloading a bit. We'll have to perhaps play with the circuit a bit. Oh, and it's gone. Oh no. Oh, hang on. That's the connector shorting out, that's why it was cutting out. Now the sound quality is not brilliant. In fact, let's see if we can get over onto medium wave, because I think we're on long wave there. Let's... where is it? Oh, try that. There's something there. It doesn't sound very happy on medium wave, it sounds far happier on long wave actually. The chip's not getting hot, is it? No, freezing cold. Now that could be another fault. I don't think that's anything to do with the amplifier. Perhaps it's just my hand coupling over the radio that's causing it, because there we go. Not very loud. I think we're going to have to experiment with the little amplifier here, see if we can get that a bit better. That just as an experiment. Let me try putting that gain cap in circuit. I'm just going to try shorting it into circuit, see what the difference it makes. I think... Let's try that. Yeah, it definitely makes... There we are. It's probably a little bit too much, a dead short like that. I think about a 1K resistor. I might try a 1K resistor in there. So we've just got a bit more gain, but not quite the full gain of like the 10 UF cap just on its own. I suppose what I might actually do is just stick a little pot in there and have a play with it and see if we can get that a little bit better. Let's see if it makes any difference on the audio if we disconnect the other side of the speaker from the main board here and just connect it onto the circuit board, onto our little amplifier board. Because at the moment, so the ground is going through part of the original circuit, I think. I don't think that's going straight to... I don't know, it could be going straight to ground. Can't really see with this screen, with the way that this board's made. Let's just try, just for curiosity's sake, disconnecting it from the original board and just connecting it straight onto the ground point that we've got on the new little amplifier board, and see whether that's going to improve it. I don't think it's going to make a lot of difference actually, but oops, let's try a little bit of extra solder on there. There we go. Let's try that again. I don't think it's going to make a huge difference, but it's worth a quick try. Just see if it clears some of the distortion up a little bit. Right. Let's try that again. It don't like that, does it? Oh. No, it doesn't like that. Now, I was expecting that to perhaps work a little better, not work at all. Most odd. Let's put that wire back where it came from, and just make sure that the radio plays again. I'll just tack it on this side. Are we on there? No. There we go. Let's just tack back where it was, and let's try the radio again. Apart from a lot of squealing.
To other people, if we wear a face mask under certain circumstances, but everyone tries to emphasise the fact that no face mask is as good as effective social distancing. So if you've got yourself more than
no, it prefers the ground for it over there. I'm going to go and see if I can just find a 1K resistor just to stick in that gain circuit and see if that's going to make any difference. So we're back as soon as I've done that. Right, we're back. Sorry about that. I've had a few camera issues. My card keeps saying that it's corrupted. Anyway, we've pretty much got this thing back together. I think I've just got one, wherever I've put it, one more are them standoffs to, oh there it is, where them standoffs to stick in there. And if we can get this in, I think that's pretty much as we can do with it. Yeah, why won't that go back in its hole? What's stopping that going in there? I am shoving it in the right, yeah. I'm sticking it in the right hole line. That's that one. Sure that came out of a hole up there. No, it can't have. Where does this one come from? No, it can't have come through there. Oh, this is odd. That one. Let's screw into something there. No, there's nothing there for it to screw into. So where did this one come from? It can't go up there because there's nothing there. Even if, oops. No, that's the tuning thing. So where on earth did this other post come from? You know. Oh, is it there? It's there. That's it. It is the one that's right at the end there. You daft sod. I'll give them a quick tweak up. Well, basically that's the radio all back together. Fortunately, I can just fit my little board. I'm not going to try and glue it in or anything, because if you can ever get the right part for this, I suppose we can stick the right part in. I can also perhaps stick that heatsink, which we're not going to need that on. I don't think we're going to need that on the IC, being that it's not actually being used for any power output. It's just the rest of the IC is still doing what it's meant to do. So I might just stick that in the battery compartment, stick it down somehow. But that is just going to sit literally in there like that. I have connected the dial light back up. It's a bit of a weird thing, the dial light. I've looked back on the circuit diagram and it seems that the dial light, it runs through the speaker, and that seems to be some kind of diode thing, rectification thing. So it uses like pulses from the speaker that it rectifies and steps up in. This is, as far as I can work out, that seems to be what it's doing, steps it up in voltage to run the dial light. Anyway, I've tried connecting it back up. I tried hooking it up to my little amplifier board in the same way that it was connected up to the original, and I can't get it to work. What I might do if I revisit this is just use a bright LED and a 1K resistor and connect it in with the 9 volts, and so when you press the button it lights the LED. That's probably the more modern, simpler solution to actually getting around that. But I'm not bothered about a dial light. I don't really need a dial light. I've still got the 9 volt input if I want to run it off a wall wire. I've still got the headphone output. They work fine. I've got them. They're all dialed in. They're connected in. They work. My little amplifier board seems to be doing what I want it to do. It is working. I can switch the radio on now. It's a bit how are you doing because I've not got anything screwed in yet, but you can see we can tune stations then.
You know, if you're feeling a bit lonely, a bit isolated, just pick up the phone and talk to somebody, whether it's football or not. Yeah.
So what I'm going to do, anyway, I'm just going to get this thing back together. I'll stick the case back on and we can have a final look at it when it's all back together, and have a quick play through long wave and medium wave and what have you. So back in a sec. Okay, and there we go. That's the radio basically finished. Well, at least for now. I probably will revisit this, especially if I can find the correct IC for it and put the correct one in. But possibly you'll get the dial lamp to work, even if we have to do a bodge and fit an LED. It's still possibly better than it not working. It's not something you'd really use all the time. But I'm reasonably pleased with it, seeing we've gone from a completely dead radio to switch it on.
Whether older people are feeling
to speed with some of the new.
It picks everything that all my other radios pick up on medium wave. You know, goes reasonably loud. Doesn't distort, doesn't feedback. You know, it's not too bad that. It's a pity the dial light doesn't work, but let's try it on long wave. Oh, hang on. Just back, so I think when I put the back on, I just caught the wave train switch because it's not switching over, so just back a sec. Well, that was a faff, but I managed to get it in. That wave chain switch is not good on this. It's a horrible little like wafer switch you can't get into because it's all encapsulated in plastic and it's got some rather iffy contacts in it. Anyway, we'll switch back on.
For your Saturday night, we're in together round at your
We'll switch over to long wave. And you see, we do actually go over to long wave. Not a lot on it, but
American troops were patrolling near the Ho Chi Minh Trail on the Vietnam-Cambodia
yeah, it's radio 4.
That's documented in a CBS
Picking up a lot of buzz from my lights and my camera, unfortunately. But I'm not really going to use this on long wave, to be honest.
On campuses, the division stoked by Nixon's campaign to paint students as a kind of enemy.
So we're picking some interference up there, but that's just from various switch mode power supplies that I can't really do a lot about.
In cooperation with the armed forces of South Vietnam,
But if we,
attacks are being launched.
we'll switch over onto medium wave.
She do? What shouldn't she do? And all this is really,
You know, it's not bad at all on medium wave. I'm quite pleased with that, especially considering I said we've got a hacked-in amplifier in there.
To keep her boss essentially.
Seems reasonably well matched to the speaker.
Please play some Cult, Sturge, says Terry from Norfolk.
So there we are.
After 9 Tezza.
So that's
Daryl says, yay.
a VEGA 404 made in USSR. So they started making these in '78. This one's from '82. But yeah, I'm reasonably pleased with that. It's not perfect. Like I said, that wave change switch, I will have to have another go at that wave change switch. Perhaps see if we can get the dial light to work. I don't think I can get it to work the way it did, but that could be to do with the amplifier that we're using. It could be that little strange black box that the bulb's connected to's failed. I'm not sure whether we know the bulb's alright and we know we tensioned that switch and that's working. But yeah, I hope you enjoyed that little repair video. Hopefully I'll be doing a few more. I will get back onto some computers because I've got some bits I need to get on with computers. Mildred's ashtray is still staring at me and saying, come on, fix me. So I want to get back on with that. I'm having a problem with my Amiga 600. Some of the keys have stopped working, so I suppose we better have a look at that. So there's going to be a few bits and bats coming up in the future. Carry on with the garden and the workshop and other things. Right, I'm going to leave it there for now. I hope you enjoyed that little repair video. So thanks for watching and goodbye.